Assalamu alaikum. Welcome to lecture number 29 of Software Requirements Engineering CSE305. And in today's lecture, we are going to continue our discussion on requirements engineering in Agile methods. We started discussing requirement engineering for Agile methodologies, and we were towards the end of our previous lecture, we were discussing and looking at a specific Agile method, that is extreme programming. And we were trying to figure out that the things that we discussed in journal about requirement engineering for Agile methods, how they are applicable for a particular method. So that's why we started looking at extreme programming. And we will continue doing that today. And if time permits, we are also going to start our discussion on our next topic, and that is methods for requirement engineering. So as I just said, that we started our topic on requirement engineering in Agile methods in a previous lecture, and the whole discussion was based on the fact that these Agile methodologies, they are based on the principles of lean production. So their foundation lies in that principle of lean production. And so we know that these Agile methodologies, they are based on principles of lean production. And lean production says that identify and remove waste from product development. So, and what is the definition of waste? So waste is defined as anything not required by the customer. So anything that the client does not want is a waste. So when we say we are doing lean production, we identify all those things which are not desired by the client, and we only do what does actually the client wants. And this is the principle on which these Agile methodologies are based on. And that is why often people have a view of Agile methodology, okay, that when we are following Agile methodologies, we don't have to do lots of documentation, and it's a very informal methodology. And as I emphasized on this fact that these Agile methodologies, they are more formal than any other software development lifecycle model that we know of. So if we are following these Agile methodologies, we need to be very formal. We need to stick to the practices of a certain Agile method that we are following, and that is of utmost importance. But so specifically, now coming to our topic, that was requirement engineering in Agile methods. There are two principles on which requirements are engineered in Agile methodologies. Number one is reduction of waste. So reduction of waste is the first principle. The second one is evolution of requirements. Now this is actually straight away an adaptation of the principles of lean production, because we said that in the lean production we identify and remove waste. So we are saying in Agile methodologies, requirement engineering is based on two principles. The number one is reduction of waste. So this reduction of waste concept is exactly the same. So how and why these Agile methodologies think that there is waste if in when we are following these other methodologies? The problem with other methodologies is, for example, let's say we are doing a waterfall model, or let's say we are doing incremental model. Now what would happen that we start gathering requirements, we do lots of elicitation, then we do elaboration, and then we do negotiation, specification. So we spend lots of time on actually understanding the requirements, analyzing them, planning them, designing the product on the basis of them. But the fact is that these Agile methodologies, or the people believe, or the proponents of these methodologies, they believe that requirements are going to change. So if something is going to change, then why spend too much time on it? And secondly, how Agile methodologies believe that there is waste generated as the result of the requirement engineering practices. Because in a traditional model, what normally happens is, let's say this is our set of clients. So this circle, it represents the stakeholders or the clients from which we have to elicit requirements. Now what happens in a traditional model is that you have a requirement analyst, and this requirement analyst is going to talk to these stakeholders to gather requirements. And then he is the person who is responsible for specifying, negotiating, and doing everything, and generating a final SRS. And that SRS is used by this group of developers and designers. So there is a gap between the people who have actually who are supposed to develop and the people who want something to be developed. And because there is this gap, so lots of problems are generated. So the result is that we need all those extra steps that we need to follow in requirement engineering, or that we do in requirement engineering sub-processes. So that is why maybe we need more negotiation. That is why we need to be more careful when validating requirements. That is why we need to spend time more on analysis, because there are lots of ambiguities, because this person interprets customer requirements depending on his own understanding, and on the basis of his interpretation he is going to specify those requirements, and the developer is going to take that up. So what does agile methodologies do in order to get rid of that waste is that when we are gathering requirements for any of those agile methodologies, these developers, they are directly in touch with the client. So multiple practices are being followed. The first practice is that customer involvement is very high. So customer involvement in agile methodologies is very high, and we discussed towards the end of our previous lecture that this is one of the factors. If customers are not available, then you cannot follow an agile methodology, because that is a prerequisite of following an agile methodology, that your customer is readily available. And because customer is readily available, and when you are gathering requirements, the developers, they are directly in touch with the customer, so they directly talk to the client. So there is nobody between the developers and the client. So it means that we are reducing ambiguities, we are reducing problematical requirements. So the developer is directly getting something from the client, and on the basis of that they are developing it. So but that puts another constraint on these agile methodologies, that the developers that you have when you're following agile methodology, they need to be more versatile. They need to have more skills. They need to be good in communication as well. Not only good in development, but they need to be good in communication as well. So these are the things that agile methodologies they deploy in order to reduce the waste from the requirement engineering process. The second principle when it comes to requirement engineering and agile methodologies is evolution of requirements. And this principle, it is based on three main hypotheses. This evolution of requirement is based on three main hypotheses. So the first hypothesis is that requirements are not well known at the beginning. So the first hypothesis is that requirements are not well known at the beginning. So that is the first hypothesis on which this principle of evolution of requirement is based on. And the second one is that requirements are going to change. It does not matter, whether what is the level of understanding. Requirements are going to change, because with time there are different things which will happen, and requirements are going to change. So that is the second hypothesis. And the third hypothesis is that change in requirements is not expensive. So that is a third hypothesis on which this principle of evolution of requirement is based on. And again, now the question is that these two are the principles. We have already seen that how agile methodologies deal with that principle of reduction of waste. Now how do they deal with this principle of evolution of requirements? In extreme programming, as we said, or in extreme programming, that is one of the agile methods that we started discussing in our previous lecture, or in any agile methodologies, the mode of development is iterative or incremental, but the size of these increments is very small. So what happens is that we are splitting requirements into small iterations, and before every iteration we do requirements prioritization. So we prioritize our set of requirements before each iteration. So that actually means that our pool of requirements is up to date at all the time, and we are exactly doing what the client wants, and we are not wasting our time on something which the client does not want. And secondly, because customer is so readily available, so whenever you produce something and you want feedback from the client, you are straight away going to get it. So again, you don't have to wait for that too long, and on the basis of feedback you will resolve all the problems and then take it back to the client to get his feedback again. So these are the two main principles on which these requirement engineering in agile methodologies is based on. And as I said in a previous lecture, we started looking at one of particular example of a certain agile method, that is extreme programming, and we will continue our discussion on that in today's lecture as well. So as I said, today's lecture is a continuation of our topic on requirement engineering in agile methods, and secondly, if time permits, we are also going to discuss methods for requirement engineering. This is a slide which we finished our lecture on in the previous lecture, and we will just continue with that. So extreme programming and agile principles, first of all we need to figure out, because as I said, we started looking at one particular agile method, and that is extreme programming. So this is a agile method, and we are going to first of all see that how it actually follows those agile principles that we discussed earlier. So again, incremental development is supported through small and frequent system releases, so it does support incremental development. Customer involvement means full-time customer engagement, so it wants that the customer be fully engaged in this process. And people, not process. So one of the very important principles of agile methodologies is, or agile methods is, that you give more importance to people than processes and tools. So it does, because it has following things that it follows. It has pair programming, it has collective ownership. Why collective ownership? Because all the team and all the developers, all the designers and the manager, they sit together and they decide together that how much time a certain iteration is going to take, and everybody takes ownership of the task that he or she is going to do. So there is more emphasis or more belief in people than on the processes. And change is supported through regular system releases. As we said that, if you guys remember, we drew a very small life cycle of this extreme programming, and we said that it has different phases. So you plan an iteration, then you spend some time on designing, and then you actually develop, and then you actually test, and then there was this release, and then you plan again. So that was the extreme programming cycle basically. And we discussed that the size of an iteration is very small, and we also discussed that there can be multiple builds of a product in a day, and maximum size of an increment, it cannot be more than 2 weeks. So each iteration you are going to plan, it cannot be of more than 2 weeks. So you can imagine that by following these principles, we are actually sticking to those two principles of reduction of waste and evolution of requirements, because we believe that it can happen that within 2 weeks customer changes some of his requirements, and if it happens, then we would know after 2 weeks, and again we will prioritize again, or we will give this to client, and based on his feedback, if there are any changes, we will get to know straight away. So it again, if you look at it closely, then it is actually following those two principles of reduction of waste and evolution of requirements. So this is how extreme programming take care of all those agile principles, or it is agile method because it follows those agile principles. So how customer involvement is ensured? Customer involvement is a key part of extreme programming, where the customer is part of the development team. So you consider the client to be part of your team, because he is so frequently in touch with you. You are discussing all the problems with him, you are showing him different builds, you are waiting for his feedback, and he is part of the prioritization process when you decide which iteration you want to plan next. So he is actually part of the team. So the role of the customer is to help develop the stories that define the requirements. So that is very relevant to our course, and what we are trying to discuss is that customer is the one who helps us in developing these user stories. So in agile, in extreme programming, the requirements, they are taken from user stories. So remember, we called scenarios. So it is something similar, that customer helps build us these user stories on the basis of which we are going to plan our iterations. We are going to talk about that, to help prioritize the features to be implemented in each release. And then out of these stories, you basically prioritize that which features you are going to build first. And this is important. We are not saying that you prioritize these user stories, but you prioritize these features, because I mentioned that the maximum size of an increment. So imagine that maximum size of an increment is 2 weeks. And so if there is a user story, and you start planning it, and then you realize, okay, no, this is actually going to take 3 weeks to build. So you will decompose that. So you will select some of the features from these user stories, you're going to prioritize them, and you are only going to do those which you can finish within this 2 weeks of time constraint that you have when you're following extreme programming. And the third involvement of customer is to help develop the acceptance tests which assess whether or not the system meets its requirements. And as we discussed, that before you release any build, it is tested against all the test cases are run on it, because their changes are so frequent when you are following these agile methodologies that you do not know whether you have changed some functionality which you provided to the client in your previous build. So you basically test it against all the test cases. So customer role is very important in agile. First of all, it helps define those user stories or develop those user stories. Secondly, customer helps in prioritizing the features that you are going to implement in a certain iteration. And third is, customer helps in building or developing those acceptance tests against which whether it will be assessed whether the build that you have made or your current release, it meets the requirements or the feature that the customer actually wanted. So customer role is very important, and remember that the customer role importance was that it helps in reduction of waste. Number one, how it is helping in reduction of waste? Because client is frequently in touch with you, and if client is not available readily, then what would happen, or what normally happens in traditional lifecycle models, is that requirements change, but you do not have any interaction with the client, or client is not available. And when you go to him after 6 or 7 months, then client says, okay, no, I want, there were some changes, and we didn't have time to talk to you, and these kind of things. But because in this extreme programming, your customer is so readily involved, and he is actually giving feedback, he is there in planning, so you are removing waste. Okay, so that is very important. And secondly, evolution of requirements is also taking place. So customer is helping in achieving these two principles which are followed, on which the requirement engineering for agile methodologies is based on. So customer role is very, very important. Then what are these requirement scenarios, or what are these user stories? This is of specific interest to us. So in extreme programming, user requirements are expressed as scenarios, or in literature it is frequently mentioned as user stories. So normally we say that requirements are gathered in the form of these user stories. And why do we call them a story? Because when you talk to a client normally narrates his experience of the product, or the way he deals, or the way he performs a certain process as a story. So what he is going to say, okay, we actually we log into the system, and then we do that, and then this problem happens, so we want a solution for that. So when they are going to explain that, so it will appear as if they are telling you a story. So that is why these are called stories. And one thing very interesting, that as I said, that when we are following a certain methodology, we need to be very formal. And what extreme programming believes is that these stories, they are written on cards, and the development team breaks them down into implementation tasks. These tasks are the basis of schedule and cost estimates. So normally what happens is that imagine that this is an A4 sheet that we normally print, that is the normal size of the paper that we have. Now these cards, they are actually smaller. So this would be the size of the card on which these stories are written. The reason why these cards are smaller and in size, because there is only so much that can be written in them, and it automatically restricts the detail that you can put in a user story. So if you are trying to define multiple things, then you would need another card to mention another user story. So there is no limit on the number of cards, but to express one user story, there is one story card. Okay, and you take this whole story from the client, and what the team does then, it tries to identify what are the different tasks that we need to do in order to achieve this set of features that client has requested. And you get these tasks, and on the basis of these tasks, all the teams sit together, and then different team members, as we said, that the emphasis is more on people. So all the teams sit together with the project manager, and then they decide how much time each task is going to take, and on the basis of that they plan the whole iteration. And people, so the life of the project manager is a lot easier in agile methodology. Why? Because we believe in our team, okay, and the team, because they are part of this planning process, they take ownership of everything. So people would raise their hands and say, okay, I will do this task in this many number of days. And because nobody is actually forcing them to say that, they are doing it on their will. So they are responsible for that, and so that is how the whole dynamics of this, agile methodologies, they work. And then the customer chooses the stories for inclusion in the next release based on their priorities and schedule estimates. So what you're going to do is that all the user stories that you have elicited from the client, so elicitation is, let's assume, the same. The difference is there is a difference in roles, who is going to elicit. As we said, that developers are directly now in communication with the customer. So you're following elicitation, you gather different user stories, and now you have to decide, okay, which one to build first. So again, remember, as we discussed in our previous slide, that the customer role is important in prioritization. So let's say you have these two user stories, and you have decided that this one is going to take 10 days and this one is going to take 12 days. So now you are going to, or let's say this one is going to take 8 days, so for the sake of simplicity. Now the client would look at these two, and depending on his preference, he would tell you, okay, I want this one to be done first, or this one to be done first. So you will pick one and you will just start working on it. And so this is how these scenarios are generated from the client, and what is the role of client in this, in the prioritization of these scenarios. So this is an example story card. Now look at that this is a small card, and we have given it a title as well. So the title says downloading and printing an article. So this story is about, or this scenario explains that how do you download and print an article from this system, from this particular system that we are developing. So first you select the article that you want from a displayed list. You then have to tell the system how you will pay for it. This can either be through a subscription, through a company account, or by a credit card. So and after this you get a copyright form from the system to fill in, and when you have submitted this, the article you want is downloaded onto your computer. You then choose a printer, and a copy of this article is printed. You tell the system if printing has been successful. If the article is print-only article, you cannot keep the PDF version, so it is automatically deleted from your computer. Now imagine that this is the story that client has explained to you, or client has helped you develop this story for downloading and printing an article. Now there are lots of small tasks that different people would be responsible for. Now how that is actually achieved? If we look at this statement, then the first thing is that you need to display all the articles. So maybe first feature that you have to build is that you have to display all the list of articles that you want. Or you want your system to have a search facility where when you search for an article, then it displays the list of all those articles. Okay. And then you select that particular article, and when you press this selection button, the system should ask you for payment. So the next set of features is for payment. So the first is display article, and the second is payment. And then there are features which are related to copyright form. And then there is small functionality of downloading that article, and then printing. And finally there is something interesting here, that there are some articles which are only print only, and you cannot keep the PDF version, so that you can at times the copyrights limits that. So there is this functionality that once the document is printed, then it should be automatically deleted. So automatic deletion is something else as well. So this is how, from a user story, these tasks are identified, and on the basis of these tasks, for example, these are the 6 possible tasks that you have identified from the story. Now different team members of yours are going to say that, okay, I will do it in 3 days, I can do it in 2 days, this can be done in a day, this can be done in a day, this can be done in 2 days, and I don't know, and this can also be done in 2 days, and so you get these kind of. So the next thing that you do is schedule it. So you schedule it and see which tasks are dependent on each other, and on the basis of that you identify, okay, this iteration is going to take maybe 10 or 8 or 9 certain number of days, and you do it for all the stories, and then the client is also going to tell you, okay, which one you're going to do first. So this is how a story is mentioned, and if you look at it, then all the things or all the features in this particular story, they are related to one big functionality, which is downloading and printing an article. So we are not saying multiple things here, that how you upload an article. or how you store articles in your system, because that might be a different story. So this is important, that we split requirements. And remember, we discussed that in reduction of waste, that one of the techniques that is used to reduce waste is you split requirements and you decompose them into smaller iterations, and we talk about similar functionality only in one user story. So this is one of the things which also explains that how reduction of waste is done in agile methods. Okay, and then how extreme programming handles change in these requirements, because remember, one of the main sub-processes of requirement engineering is requirement management, and requirement management deals with changes in the requirement. So how XP handles these changes. So the conventional wisdom in software engineering is to design for change. So normally, remember that, as I discussed at the beginning of this lecture, the traditional models or the traditional requirement engineering processes that we have covered, we spend so much time in elaboration and analysis. Why? Because we want to understand the system thoroughly. We want to understand the system thoroughly because we know in that as well that requirements are going to change, but we increase our understanding so that whenever a change comes in, we can take a better decision and we can handle that change in a better fashion. That's why we design for change. And we believe that it is worth spending time and effort anticipating changes, as this reduces cost later in the life cycle. Remember, all the traceability effort that we go through, we do it because we believe that change is going to happen and we need to be prepared for it. We need to estimate changes and we need to be ready for it. Whereas these agile methods and extreme programming, they maintain that this is not worthwhile, as changes cannot be really anticipated. So they have a totally opposite approach, and in these agile methods, they believe that you should not be actually wasting your energies in anticipating changes, because you cannot really anticipate them. So that is what they believe. So rather, it proposes constant code improvement, refactoring to make changes easier when they have to be implemented. So what they do is, they, in particular, Agile have a principle which is called refactoring, or there is something which Agile follows. This is called refactoring. So what you do is, in refactoring, is that whenever a change request comes in, you go back to your original code and you start improving it, or you start making changes in it. And because you have planned your iterations so small, that it believes that refactoring, and another important factor is that in refactoring, you only look at that portion of the code which is desired to be changed, and you again are going to test it against all those test cases. So refactoring is used to handle changes in extreme programming. And again, it's a different way of thinking about solving problems. And agile methodologies and extreme programming, they believe that you don't design for change, because you cannot anticipate changes. Whereas the traditional models, and they also work and they are being used in industry as well, they believe that we need to design for change. We need to be really prepared for it. These are just two different perspectives. So what is this refactoring? So refactoring is the process of code improvement where code is reorganized and rewritten to make it more efficient, easier to understand. So as I said earlier, that when you are, because these agile methods, they believe in delivering something to the client or delivering functionality to the client. So you will not be spending too much time in looking at how good your code looks, how many comments you have in it, and whether you are following all those practices that you have or not. Your emphasis would be on developing this particular increment and getting it and building it and making a release so that you can give it to the client. So that is your emphasis. But you have certain standards and you want to improve your code, so you will get back to it and you will do it later. So refactoring is required because frequent releases mean that the code is developed incrementally and therefore tends to become messy, because our increments are very small, and in one increment we do something, in another increment we do another thing, we might have a change in the next increment, so our code might may become really messy. So we need a process to actually get that in shape, and refactoring is one that is actually used to do it. So refactoring should not change the functionality of the system. So essentially, when we say refactoring is something which is used by Agile to handle changes, refactoring as such does not mean that you change the code. So you change the code based on your client request, and you might have a small increment to actually do that, or another small release to actually do that. But it will mean that you have made so many changes in your code that it is not very clear. I don't know how you guys develop. When I used to develop, and even as a student, and when I was working with different clients as well, then what you normally do is that when you're making these small increments, you build something, you show it to the client, and the client says, no, this is not one. Then you basically comment the whole chunk of that code, and you start working on something else. And this is how you can think that this is how people are going to work in this agile environment where changes are coming in so frequently. So your code can become really messy. So refactoring is a process which actually makes your code look better, makes it more efficient. But remember, the emphasis is on that it should not change the functionality of the product. So the final functionality, it should not change. And automated testing simplifies refactoring. As you can see, if the changed code still runs the test successfully. As I said, that even after refactoring, you need to be sure that your product is working as desired or as the client wanted. So we test it against all the test cases that we have written. And if you have automated testing, all the better, because it would actually save you a lot of time. So how testing or test cases are developed in extreme programming? Because remember, we talked about that in traditional requirement engineering, then SRS, once it's prepared, it is used, test cases are developed against it. And remember, we discussed in validation, one of the processes of requirement engineering, that when we build these test cases, then this is another way of validating the requirements. Why? Because when we are going through that document, we identify whether all the requirements, they are testable or not. And if a requirement is not testable, and when a requirement cannot be testable, because if a requirement is incomplete, then it is not testable. You cannot actually exactly define a test case for it. And we saw different examples of, if a requirement is ambiguous, you cannot really write a test case for that. So if a requirement is not quantitatively described, you cannot write a test case for that. So we said that testing is a useful way of validating your requirements, and SRS is used. So SRS is developed first, and then you do that. Whereas in extreme programming, there is this concept of test first development. So you develop your test cases, and then you go into development. So each developer, once he take up a certain task, for example, if you remember from our last story card, that displaying the article. So whoever is responsible for developing that particular feature, he is going to define a test case, that how am I going to test this particular functionality, and after that he is going to start development. So incremental test development from scenarios. So testing is incremental, as the agile methods, they are incremental. And user involvement in test development and validation. And remember, we said that customers are part of this acceptance test creation process. So customer would be actively involved in developing those acceptance tests. So again, so you are saving a lot of time, and you're reducing waste, because customer already knows, that whether this product would be tested against what. So you do not actually have to do that final testing in front of the client, because customer has already prepared those test cases with you. Customer would test it on his own, but you do not have to do that formally again, because customer was part of this process earlier as well. So automated test harnesses are used to run all the component tests each time a new release is built. So this is how normally testing is done in extreme programming, and these are the task cards for document downloading that we have just seen. So what you do is that from those user story, we identify different tasks, and then we try to put in detail of each task, that what do we actually need to do for each task. And just look at this implement payment collection. So remember, one of the features that we said was payment collection. So how do we actually describe it in more detail? And this is how a developer would do it, because first he would have to actually decide, okay, how am I going to test it, and then he start going to develop it. So payment may be made in different ways. The user selects which way they wish to pay. So remember, whenever you display an article, so the system displays the payment options, and then the user is going to select a particular payment option. If the user has a library subscription, then they can input the subscriber key, which should be checked by the system. Normally, you would have seen that, what happens in a university, for example, different universities have access of different journals. For example, ComStats University, we have access to different IEEE libraries and different IEEE journals. So whenever we go and visit those websites from an IP address from ComStats within a university, what happens is that it identifies that, okay, this is a subscriber and he can actually access it. So we don't actually have to pay for them. We can actually download them, we can print them, and we can use that. So this is how subscription actually works. Alternatively, they can input an organizational account number. So this is another way which can be done. If this is valid, a debit of the cost of the article is posted to that particular account. And finally, they may input a 16-digit credit card number. If that option is not workable, then you might need to do payment through your credit card. And then this whole thing need to be validated as well, that whether the credit card number was valid or not, or whether the account number was valid or not. So in these two cases, not the subscription, but even in subscription as well, but that is automatically done, so you do not actually, so in the functionality you need to actually do that as well, but as a user you won't actually see it because you are already a subscriber. So there would be some sort of validation. So whatever payment method somebody selects, it needs to be validated as well. So these are the steps that a developer has to do. So the tests need to be defined for each task separately. So what would be the test case description? That test credit card validity. So out of those three options, we are just checking the final one, that whether the credit card number was valid or not. So a string representing the credit card number and two integers representing the month and year when the card expires. So these are the inputs. So we know what are the inputs to this particular test, that we have a 16-digit credit card number, and we have two separate digits, which one represents the year and the month of expiry of the card. So what are the steps that I need to do? Check that all the bytes in the strings are digits. So because the credit card numbers, they are only digits, they are not they are not alphabets. So you first thing you need to show that it's a numeric 16-digit string. And check that the month lies, so there is a field for month, and somebody has not mistakenly entered 13 there, because we only have 12 months. And then you actually check for years as well. Using the first four digits of the credit card number, check that the card issuer is valid by looking up the card issuer table. So normally you have these card issuer tables, and different card issuers have different, so you need to check the first four digits. On the basis of that, you decide whether the issuer is valid or not. Check the credit card validity by submitting the card number and expiry date information to the card issuer. So first thing is you identify the card issuer, and then you send those details to the card issuer to establish the validity of the card. And on the basis, we are also defining that what would be the output. So the output is that okay, or if the card is okay, then we say okay, and if there is an error, then we will tell that there is an error. So this is how this whole thing is done. That, remember, we had this user story. From user story, we expanded that into different tasks. And remember, we talked about that. But when we started developing, we expanded those tasks. And when we expanded them, we planned some test cases, and then we started testing. Then we started developing. So test first development says that writing tests before code clarifies the requirements to be implemented. Now, why we are talking about this? Because remember the validation process of requirement engineering. So Agile methods, it does all those things that we have talked about in those requirement engineering sub-processes, but it just does them in different ways and by different names. So this is a way of validating requirements, as we discussed earlier as well. Because we are developing these test cases first, and then we are developing, so remember the waste reduction principle? So it is actually ensuring that we are removing waste, because we are developing test cases first and we are clarifying requirements. Because if we cannot actually write a test case for a certain requirement, then it means we need to go back and ask the client, oh no, we do not understand how we are going to validate this. So we go back and talk to him. So tests are written as programs rather than data, so they can be executed automatically. Normally in Agile methodologies, you have automated testing. You don't want to spend so you do not have these resources separately which are testers. And in bigger corporations worldwide, the concept of testing is different now. So people believe in test first development. So they believe that you write these automatic scripts to do the testing, and developers are responsible to test their own code. You do not have, so the role of testers is actually diminishing. So that is what you need to prepare for. So you need to actually look into what is test first development in more detail, as a student of software engineering as well. So all the previous and new tests are automatically run when new functionality is added, thus checking that new functionality has not introduced errors into the system or not induced errors into the system. So we have seen different things in Agile, specifically in extreme programming. We said that customers are hugely involved, and by customer involvement we are reducing waste, because customer is so readily available. We are not doing anything which the client does not want. And secondly, because customer is available readily, so requirements are evolving as well when they need to, and we do not have to wait for a longer period and then get to know that client requirement actually changed. So requirements are evolving very frequently, because remember the hypothesis that requirements are not clear at the beginning of the product. So that's why we have small increments. And then we looked at how these requirement scenarios are generated. Customer develops those user stories with the client, and then based on those user stories, tasks are identified, and on the basis of those tasks, schedules are made, and on the basis of those schedules and the cost, client is going to prioritize, do a prioritization of requirements. So remember, negotiation as well is also part of it. And then we said how the test cases are developed and how test first development helps us validate requirements. Remember the validation process. And then we also looked at change, which was one of the main topics of when we discussed requirement management, because requirement management was concerned with change. So we saw that because changes are done very frequently in those agile methods, so there is this principle of refactoring, specifically in extreme programming, which talks about improving your code or making it more efficient, so that when you release your final product, it has a very efficient and very well written code in it. So normally, so the question then becomes, are there any tools for requirement management in agile methodologies? So yes, there are, and all the UML modeling tools, they can be used. Requirements negotiation tools, they can be used, because remember, requirement negotiation is very important and is done more frequently than any other traditional model, because before each increment we are doing negotiation. Then we have these instant messaging tools, which are often used for elicitation and negotiation as well. Then you have all those project management tools, and normally, because the customer is considered part of the development team, then at times the client, they also can see the progress of your project as well. So they are also a user into your project management tool, and they can actually see how many tasks have been done or what is the status of our current iteration. So there are different tools which can be used for managing requirements in agile methods. So that is it from our discussion on requirement engineering in agile methods. And now we are going to start our next topic, and that is methods for requirement engineering. And this would be the final topic of this particular course. And so first of all, we need to understand that what are these methods and what is the role of these methods. When we say methods for requirement engineering, so what is the role of these methods in requirement engineering? So the process of requirement engineering is usually guided by a requirement method. So this whole process, so remember the process that we discussed. We said we had inception, we had elicitation, elaboration, we negotiate, specify, we validate, and then we manage these requirements. So this was the process. So the process, or the way this process is followed, it depends on the requirement method that is being used. So some might put more emphasis on validation from the beginning, some may not. Some might put more emphasis on specification, some may not. So this is where the method induces, this is the role of the method, that depending on the method that you're going to use, you are going to start these different tasks or different sub-processes of requirement engineering at different times and put different emphasis on these differently. So requirement methods are systematic ways of producing system models. These system models, which are an output of these requirement methods, they bridge the gap between the analysis and the design process. And we have talked about it when we discussed analysis. We have discussed some of those models. So again, we are not going to spend too much time on them, but we are going to see that under which method we produce which kind of system models. So that is what we are going to talk about in this part of the course, or in this particular topic. So what are the necessary properties for a requirement engineering method? So the first one is suitability for agreement with the end user. So that is the first thing. The precision of definition of its notation, assistance with formulating requirements, definition of the world outside, scope for malleability, scope for integrating other approaches, scope for communication, and tool support. So these are some properties of different requirement engineering methods, and different methods would vary on these different things. But necessarily these are the things that these methods they should have. So there is this no ideal method, and when we discuss it, you are going to actually realize that different methods have certain advantages which make it better in a certain scenario, and ideally you would want to use multiple methods, but that is very difficult to do. So when you actually decide, you actually only follow one requirement engineering method for engineering those requirements. So there is no ideal requirement method. A number of methods use a variety of modeling techniques to formulate system requirements. System models can be enriched by modeling different aspects of modeling techniques, or by using different modeling techniques they can be enriched. So what are these modeling techniques? And we have talked about them. What are these modeling techniques? We have these data flow models, we have compositional models, we have classification models, we have stimulus response models, and then we have these process models. So we are going to discuss them very quickly, because we have already remembered in analysis we discussed some of these things. So we are going to talk about them, but not in a lot of depth, a lot of detail, because the purpose is just to introduce this to you guys as well. So we know what is data flow modeling. We've talked about DFTs based on the notation that the system can be modeled as a set of interacting functions, uses data flow diagrams to graphically represent the external entities, processes, data flows, and data stores that we have already discussed. So this is a data flow notation that we already know of. We have inputs, we have a process which transforms that input into an output, and then we have an output which is actually given to an entity which is shown as terminator here, and then we also have stores where we are storing that data. So there is notation can vary, so depending on different tools that you are using. There is little uniformity in industry concerning the DFT notation. The notation shown was advanced by DeMarco. Gain and Saracen used rounded rectangles for bubbles and shadowed rectangles for sources and destinations, and squared of C's for data stores. So there is variability when it comes to notation in data flow diagrams, and different people have proposed different variations. But the purpose is still the same, that this is a method which actually helps us in knowing that, or it models our systems as a series of functions. And what these functions do, that they interact with each other and they transform the input data into a certain output which is typed by the external entity or the client. So let's look at a DFT example very quickly. So this is a library system intended to automate the issuance of library items. So we'll just quickly look at that we have this library user, and there are certain inputs that the library user will give to my system. And this is a level 0 DFT, or the context DFT as we talked about. So there is library card and requested item are the inputs, and the output to the library user is the issued item. And then there is another external entity also involved here, which is the library assistant. And he would tell if the certain item is issued or not, then what is the return date of that particular item. And this is the level 1. So we have decomposed this main process of issue library item. So we have decomposed this main process into these smaller processes. So whenever a user inputs their library card, we check whether the user is valid or not, and this is checked by this user database. And whenever an item is, remember there were 2 inputs from this user. So we check this particular item, that whether items in the item database, whether the item was available or not. If the item status is okay, then we are going to issue that. So this is a level 1 DFT of that, and we can see that there are it's basically, as we said, that this is a modeling technique which models a system as series of functions which are interacting with each other. So there are functions which are interacting with each other, and we are transforming these inputs into certain outputs. Okay. And this is part of the structured analysis that we have already covered. So Dataflow approach is typified by structured analysis method. 2 major strategies dominate structured analysis: old method popularized by DeMarco, and modern approach by Urdu. So DeMarco's approach, it's a top-down approach. The analyst maps the current physical system onto the current logical data flow model. The approach can be summarized in 4 steps: analysis of the current physical system, derivation of the logical model, and derivation of the proposed logical model, and implementation of the new physical system. So this is how it's been done. And modern structured analysis, how it actually differs from the top-down approach, is that distinguishes between the user's real needs and those requirements that represent the external behavior satisfying those needs. It includes real-time extensions. Other structured analysis approaches include structured analysis and design technique, structured system analysis, and design methodology. Next is the relational model. So data may be modeled using the relational model, specifies data as a set of tables with some columns being used as common keys. Disadvantages of relational model is implicit data typing, inadequate modeling of relations. Data model should include information about the semantics of the data. So what are these semantic models? These are approaches to semantic data modeling, include entity relationship model, ER modeling that you know of, RMT, SDM, and models identify the entities in a database, their attributes and their relationships. It uses graphical notation as well. We are going to look at one of the examples as well. So let's look at an example of this entity ER model. In an ER model, you have different entities, and those entities are connected to each other. And there can be different sort of connections. There can be inheritance, or there can be just a simple connection between two entities are interacting with each other. And then you also define that what is the input cardinality, what is the relationship between these entities, whether it is 1 to 1, 1 to many, 0 to 1, or many to 1. So you actually define that in terms of input and output cardinality as well. So there are different extensions to these entity relationship models. The basic ERM has been extended to include sub and super types of the basic entity and relation primitives. Types may have subtypes. Type may inherit the attributes of their supertypes. In addition, subtypes may have private attributes as well. Now, this is an example of entity relationship model, that you have these requirements, and each requirement has an identifier, it has a source, it has a description, it has a type, it has a priority, and it has a specification. Then requirements change as well, and there can be multiple changes in a requirement. So we are talking about just one requirement. So a requirement has changes. There can be multiple changes in a particular requirement, and these changes means that a new version of these requirement is generated. So this is just shows that, you know, if you have that, remember we talked about that if we are maintaining a requirement database, and let's say you are designing that particular system, and you are trying to use that entity relationship model to know that what would be the things that you would want to store in your database. So entity relationship model is one of the ways to actually model the data. So here we are identifying that for each requirement we are going to save an identifier, we are going to have a source, we are going to have description, type, priority, and specification. Similarly, for each change we know that there will be an identifier, there will be a description, a rationale, and an author, and we know that there is a third table which maintains the variance, or which maintains that what is the new version of the requirements. So these are the different entities, and this is how this actually tells us what are the things my system is going to have. And then we've seen that there are multiple object-oriented approaches. So closest precursor is entity relationship model. So entity relationship model is very close to these object-oriented approaches. Requirement methods based on object orientation are proposed by different authors. There is a huge list of these authors, and notations for the various methods are semantically similar. So they are similar to some extent. There is a concept of objects when we are using this object-oriented methods for requirement engineering. The objects are major actors, agents, and servers in the problem space of the system, identified by analyzing the domain. So what is an object? Objects include devices that the system interacts with. So any device, we specifically talked about it. Remember, we said that we are going to do a grammatical parse, and then we are going to identify objects. So again, this actually is very similar to that. So we say that any devices that the system is going to, that is an object. Organizational unit, that is an object. Physical location or site, that is an object. Specific roles played by humans, they can be objects. And we remember we talked about that there is a criteria that each object should fulfill. And then there are basic concepts related to these objects. There is this concept of encapsulation, then there is concept of class, inheritance, and operations or services which each object should be able to call upon. So how do we define these objects? Something real or abstract without which we store data and those operations that manipulate the data. Remember we talked about earlier in our earlier lectures when we were discussing analysis in detail and we were discussing class modeling. So we talked about that whenever we identify those potential nouns, then from those potential nouns, first of all, we classify them into those different categories, as we just saw that some can be organizational units or some devices and all those things. And then we need to actually see that whether all those potential nouns, they actually fulfill those certain criteria. And remember those criterion one, that whether this object of this particular potential class is going to need multiple operations, or do we need to store multiple information about this. So it's again, we are talking about the same thing. So some of the examples which include an account, a sensor, a software design, a car, or an organization. These objects can be composite in a way that they can be composed of multiple objects put together. So this is where we are going to end our lecture today. So let's quickly summarize what we have discussed today. So we started our lecture today again with this discussion on requirement engineering in agile methods, and we specifically talked about a particular agile method, and that is extreme programming. And first of all, we established that what are the principles, or what are the agile principles, and how extreme programming, we can say extreme programming is an agile method because it follows certain principles. So first we looked at that. And then we talked about each of those principles, and we tried to relate it to the two main principles we said that on which the requirement engineering is based on in agile methods. And those principles were, waste reduction, and the second one was evolution of requirements. So the idea was to look at a particular agile method and see how it actually deals or does these two things. So we said that the customer is hugely involved in extreme programming, and we specifically said that the customer involvement is in three main things. Number one is customer helps us in developing the user stories. Customer helps us in prioritizing these user stories. Customer helps us in developing those exception test cases. And by doing all these three things, customer is a huge part of this waste reduction thing. So customer is helping us achieve or do better requirement engineering by removing waste. So we can say that extreme programming very efficiently actually follows that particular principle of waste reduction. And then we talked about what are the requirement scenarios. So we discussed that requirements are generated with the help of the client and the developer, so they work together to elicit the user stories in the form of story cards, and then from these story cards we look at generate different tasks. Then using these tasks we generate schedule and cost estimates, and using this information the customer is going to help us do prioritize these requirements, which is part of which requirement engineering process? Negotiation. So this is the information which is used to prioritize requirements and negotiate them with the client. And then we talked about that because we say so often that agile methods are proponents of changes and they believe changes are going to happen. Remember evolution of requirements. So we talked about this particular concept of refactoring and changes, and we say that because it believes that changes are going to happen and changes are not expensive, so what it means that your code is going to get really messy. So extreme programming has a particular process which is called refactoring. And what happens in that process is that you make your code more efficient and you make it more readable and more and better. But the main principle in refactoring is that your focus is that when you change your code, you do not want to change your functionality. So this is what it is actually based on. And then finally we also talked about testing. And we said that these test cases, they are built with the customer. So this again, because customer role is there in all these three things. Specifically in terms of requirement scenarios and testing, so we are removing waste. And in terms of requirement engineering processes, remember we said that test cases, when we are preparing test cases, then we are automatically validating our requirements. So validation is done here as well, because what we do is, in Agile we talk about test first development. So test first development means that we are preparing test cases first and then we are developing. So we are validating requirements before we are actually spending some time on development. Okay, and by doing so we are removing ambiguities and we are removing waste already. So we are only doing what the client wants. So that was our discussion on requirement engineering in agile methods. Then we started looking at different requirement methods, and we said that this is the final topic of our course, which is requirement methods or methods for requirement engineering. And we said there are different methods, and we discussed what is the role of a method. We said that the main output of a method are the system models that will be generated to represent the system. And we said the choice of a method would mean that you will generate different models. And some of the methods we have already discussed in the form of, that data flow modeling, because when you are using that structured analysis approach, so that is a method for requirement engineering. The only kind of system models you are going to generate are DFTs. Then we looked at some semantic models, and we talked about entity relationship diagrams as well. We looked at entity relationship modeling. We looked at a particular example. And then we started talking about object-oriented approach, because when we are doing that, we are going to generate object diagrams. We are going to generate class diagrams. So our system models are different. So in terms of methods for requirement engineering, we said that all these methods, they follow the same process of requirement engineering, but different emphasis would be faced on different processes, and the outputs or the system representation in form of system models would vary depending on which particular method we chose for requirement engineering. So that is it from today's lecture. We are going to continue with our discussion on methods for requirement engineering in our next lecture as well. So take care, and Allah Hafiz.